Next is mapping clusters, which is one of our favorites.
Yes, it is.
So these tools, again, we're looking at clustering, but now we're going to be looking at local clustering. But first, we're going to look at the similarity search tool. This tool helps us to identify features that are similar to a feature of interest based on how similar they are by a set of attributes. So let's look at an example of that. Oh, wait, hold on.
Oh, yeah, sorry.
More of a hypothetical of that. So let's pretend that we have a point data set of potential store locations. I want to open a new store, and I can choose from any of these locations. I also have a high-performing store that I know a little something about. So I have some information about each of these store locations, the potential ones. I know the population density, the average income, and the distance to competition from each of these locations. And then I also have that same exact information for my high-performing store. So what I want to do is I want to rank my potential store locations by how similar they are to my high-performing store based on 3 variables: population density, average income, and distance to competition. So the tool is going to, depending how many results I ask for, in this case I'm going to ask for 5. Give me the 5 locations that have the most similar attributes to my high-performing store, and the tool is going to rank those 5 locations for me with an output, and we can see how that looks like.
Okay, so that tool exists both in desktop and also ArcGIS Online. So I'm going to show it in ArcGIS Online because I just think it's really awesome that these tools are being exposed to so many more people now that they're in ArcGIS Online. And it's also just, I actually just started exploring data, and it's just amazing what you can do looking at something as simple as similarity search, especially when you combine it with geo-enrichment. So basically what I did is I have all these bike share locations. And first, and I have a location that I know we had an effect that's been doing really well. And I want to figure out what other places should we be expecting to do well based on the characteristics of that location. So the first thing that I want to do is I want to enrich those locations using geo-enrichment. And so perform analysis allows me to enrich my data. And once we enrich the data, we'll have all those attributes that we need to run the similarity search. So we have thousands of variables that we can choose from. I chose data on, if we open up our table here, I chose data on age, population, per capita income, education. So I picked a couple of variables that I thought would be important or that were interesting variables to look at in terms of the success or the usage of these bike share locations. So the Find Similar tool allows me to find, first I choose that location that I'm interested in. That's my location of interest. And then I'm going to search from those enriched stores, from those enriched bike share locations, and I'm just going to choose the attributes that are important to me. And I can either choose to rank all locations from most to least similar. I can just say, show me just the one most similar. In this case, I'm going to choose to rank them all. I'll run my analysis. And the result of that analysis is that this store right here is the number 1 most similar store. It gives us the information about those variables. So we get all this information, but most importantly, we get these ranked store locations and we get a picture of their similarity. And there's a ton of applications for this. One of the big use cases that we had when we were building this tool was, I'm a local city or county, and from an economic development standpoint, I want to say, I'm just like these other cities, but here's how I'm better. So it can be really great for that kind of benchmarking. You say, I'm similar in terms of these characteristics, but here's all these ways that I'm different. So it can be really valuable from that standpoint. That was one of the big use cases we had. There's also a ton of commercial applications for the similarity search tool.
All right, grouping analysis. So grouping analysis allows us to find patterns in our data with multiple variables. So we actually group our features based on Within the groups, them being as similar as possible, and between the groups, the features being as different as possible. So the output of a grouping analysis might look something like this. There are two different ways to run a grouping analysis. We can ask for a grouping analysis where we just want to group the features, but we don't need them to be spatially contiguous, so no spatial constraints. And to do that, the tool runs a k-means analysis. And so let's say that we have these points, and this is what they look like in data space, just by value, not in locational space. So we can ask for 2 groups, and it's going to split up this way. If we asked for 3 groups, it would split that way, or 4 groups. So it's really finding the natural places to split this data into different groups based on their different attributes. So finding areas in the data space that are more similar. If we choose a spatial constraint, it's a little bit more complicated because the features have to be near each other to be in the same group also. So the tool finds different seed locations based on how many groups you want as a result, and then it conducts a minimum spanning tree calculation, and then puts the features into different groups. So it looks at how different they are in data space, but also they have to be proximate in physical space. And to interpret the results of a grouping analysis, we look at a box plot, and so we can see each of those groups, how they compare to each other based on the variables that you input into the tool. So this is a cool one. Let's see how that works.
Yeah, it's definitely one that makes a lot more sense when you just see it in action. So for those of you out there who are big nerds like we are, this is one of the most fun tools just to play around with, because you learn a lot about your data and you can explore just the different relationships that exist in your data and how things group together. I could spend all day just running this on my data. I'm guessing there's at least one other person in this room that feels the same way.
That's me.
So this is data. We're looking at data. This is from the CCAPS Foundation. This is data about vulnerability in Africa. And so what they've done is they've basically created these, they call them baskets. And these baskets are different ways to kind of think about vulnerability. So one of them is about governance. So it's this idea that if something catastrophic were to happen, what is the likelihood that the government would be able to help the population in that area, or would be willing to help the population in that area. It's also a measure of transparency and what's the word I'm looking for? No, not vulnerability. These are all measures of vulnerability. It's about like corruption, that sort of thing. So that's the governance index. Another one is about household resiliency. So that's this idea if something catastrophic were to happen, what is the likelihood that the individual households themselves would be able to feed themselves? And this has a lot to do with income levels, education levels, employment, all those sorts of things. So there's those. There's also one about population density and another one about climate change and vulnerability to climate change. So all 4 of those variables. So this is essentially, you can imagine, each of those is a variable in this data set. And so I can turn on, let's say, the household resiliency index, and I can map that. Then I can go in and change which one I'm looking at. Let's say we look at governance. Well, I can map that. So we can map all 4 of these variables, and you can imagine if this was demographic data, we could just create a bunch of different thematic maps and try to correlate them bring them together, do that grouping in our head, but that would get pretty old pretty fast. So the grouping analysis tool helps us make sense of all that data. So we're going to analyze the vulnerability data. We're going to create 4 groups, because I happen to know that that's the best number of groups, and I get that by evaluating the optimal number of groups here. There's a way to help you figure out sometimes you just have a number that you need to create, right? Like I need to create 10 sales territories. That's an obvious, you put in 10. But if you're just trying to find the natural groupings in your data, this will allow you to find those by evaluating the data. So we're going to look at the population density, climate index, household resiliency, and the governance index. We're going to use no spatial constraint. And what's really cool about no spatial constraint is that even when you don't force it to be spatial, it usually is. And that's no surprise to any of us, because everything's spatial, and it's the first law of geography, right? Things that are closer together are more related than things that are farther apart. It's Tobler's law. So it's no surprise that even when we don't force these things to be spatially contiguous, that we find these spatial patterns. And it's often the spatial patterns that emerge from this analysis that are the most interesting. So we get a lot of information from this analysis actually in our report. So if we go to the map, I think it's pretty obvious immediately, okay, we have these patterns, right? But knowing there's a green group isn't particularly useful. What's the green group? What's the orange group? We have no idea. So that's what this report is all about. It's only when we combine looking at the report with looking at the map that we start to really understand the results of this analysis. So we get a lot of information, and we are going to talk a lot more about this report in our session this afternoon. But I'm just going to focus on the parallel box plot. And so what this shows us, for instance, is, let's say, the green group. The green group, the higher this index, the more vulnerable. The large numbers are vulnerable. So what we see is that this green area is around average. So the black box plot represents the global average. And then each one of these colored lines represents where that group falls for that variable. So we can see that the green group is about average in terms of the vulnerability to climate. It's very vulnerable in terms of household resiliency, very vulnerable in terms of governance, and low vulnerability in terms of population density. Or we can see the red areas where there's high vulnerability in terms of climate index, but low in terms of household resiliency and governance, and about average in terms of population density. So we can see how each of these groups are vulnerable in different ways. So rather than just saying, okay, these are the most vulnerable areas, period, we can say these are vulnerable areas based on these characteristics. And these areas have these vulnerabilities. And so we can really use this information to understand those characteristics. And you can see, of course, that there are distinct kind of regimes here. So we see the orange area up here. It's pretty spatial, but it's similar to an area in other parts of Africa. So while we see that there's these spatial patterns, we also see that very distant places could have similar vulnerabilities also. So we get a lot of information just from exploring the spatial patterns that result from an analysis that didn't actually constrain the analysis spatially. So that's grouping analysis.